studying the edge of the heliosphere, the sun's magnetic bubble. And we're going to have a nice little simulation by NASA, the Milky Way galaxy, by NASA Goddard Space Flight Center, Image Lab, Walt Vanmeer. Now, what is this news concerning the heliosphere? By NASA's Goddard Space Flight Center, our corner of the universe, the solar system, is nestled inside our Milky Way galaxy, which is home to more than 100 billion stars. The solar system is encased in a bubble called the heliosphere, which separates us from the vast galaxy beyond and some of its harsh space radiation. We're protected from that radiation by the heliosphere, which itself is created by another source of radiation, our sun. The sun constantly spews charged particles called the solar wind from its surface, and the solar wind flings out to about 4 times the distance of Neptune, carrying with it the magnetic field from the sun. Magnetic fields tend to push up against each other, but not mix, said Eric Christian, lead heliosphere research scientist at NASA's Goddard Space Flight Center in Greenbelt, Maryland. He said inside the bubble of the heliosphere are pretty much all particles of magnetic fields from the sun. Outside are those from the galaxy. To understand the heliosphere, start by breaking apart the word, suggests David McComas, professor of astrophysics sciences at Princeton University, New Jersey. Heliosphere is the combination of 2 words, helios meaning the sun, the Greek word for the sun, and sphere, again a Greek word meaning sphere, a broad region of influence thought to be scientists are not sure of the heliosphere exact shape. The heliosphere was discovered in the late 1950s, and many questions about it remain. As scientists study the heliosphere, they learn more about how it reduces astronauts and spacecraft's exposure to radiation, and more generally, how stars can influence their nearby planets. A balloon shape? Some radiation surrounds us every day. When we sunbathe, when we're basked in radiation of the sun, kindly support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. So we use radiation from the sun when we sunbathe, for example. We use radiation to warm leftovers in our kitchen with microwaves and rely on it for medical imaging as well. Now, space radiation, though, is more similar to the radiation released by radioactive elements like uranium. The space radiation that comes at us from other stars is called galactic cosmic radiation, GCR. Active areas in the galaxy, like supernova, black holes, and neutron stars, can strip the electrons from atoms and accelerate the nuclei to almost the speed of light, producing galactic cosmic radiation, GCR. On Earth, we have 3 layers of protection from space radiation. The first is the heliosphere, which helps block GCR from reaching the major planets in our solar system. Additionally, Earth's magnetic field, the magnetosphere, produces a shield called magnetosphere, which keeps GCR away from Earth and low-orbiting satellites like the International Space Station. And finally, the gases of Earth's atmosphere absorb radiation. When astronauts head to the moon or to Mars, they won't have the same protection as we have on Earth. They'll only have the protection of the heliosphere, which fluctuates in size throughout the sun's 11-year cycle. In each solar cycle, the sun goes through periods of intense activity and powerful solar winds and quieter periods. And like a balloon, when the wind calms down, the heliosphere deflates. When it picks up, the heliosphere expands. The effect the heliosphere has on cosmic rays allows for human exploration missions with longer duration. In a way, it allows humans to reach Mars, said Eric Posner, heliophysicist at NASA's headquarters in Washington, D.C. He said, the challenge for us is to better understand the interaction of cosmic rays with the heliosphere and its boundaries. anatomy of the heliosphere. There is some debate about the precise shape of the heliosphere. However, scientists agree that it has several layers, so let's look at the layers from inside out. Terminal shock. All of the major planets in our solar system are located in the heliosphere's innermost layer. Here, the solar wind emanates out from the sun at full speed, about 1,000,000 miles an hour, for billions of miles, unaffected by the pressure of our galaxy. The outer boundary of this core layer is called the terminal shock. The heliosheath. Beyond the termination shock is the heliosheath, and here the solar wind moves more slowly and deflects as it faces the pressure of interstellar medium outside. The heliopause. The heliopause marks the sharp final plasma boundary between the sun and the rest of the galaxy. Here the magnetic fields of the solar interstellar winds push up against each other, and the inside and outside pressures are in balance. The Outer Heliosheath, the region just beyond the heliopause, which is still influenced by the presence of the heliosphere, is called the Outer Heliosheath. How we study the heliosphere outside reaches. Many NASA missions study the sun and the innermost parts of the heliosphere, but only 2 human-made objects have crossed the boundary of our solar system and entered the interstellar space. In 1977, NASA launched Voyager 1 and Voyager 2. Each spacecraft is equipped with tools to measure the magnetic fields and the particles it is directly passing through. After swinging past the outer planets on a grand tour, they exited the heliopause in 2012 and 18, respectively, and are currently in the Outer Heliosheath. They discovered that cosmic rays are about 3 times more intense outside the heliopause than deep inside the heliosphere. However, the picture the Voyagers paint is incomplete. Trying to figure out the entire heliosphere from 2 points, Voyager 1 and 2, is like trying to determine the weather in the entire Pacific Ocean using 2 weather stations, Christian said. The Voyagers work with the interstellar boundary explorer Ibex to study the heliosphere. Ibex is a 176-pound suitcase-sized satellite launched by NASA in 2008, and since then, Ibex has orbited Earth, equipped with telescopes observing the outer boundary of the heliosphere. Ibex captures and analyzes a class of particles called energetic neutral atoms, or ENAs, that cross its path. ENAs from where the interstellar medium and the solar wind meet. Some ENAs stream back towards the center of the solar system and Ibex. Every time you collect one of those ENAs, you know what direction it came from, said McComas, Ibex's principal investigator. By collecting a lot of those individual atoms, you're able to make this inside-out image of our heliosphere. In 2025, NASA will launch the Interstellar Mapping and Acceleration Probe IMAP. IMAP's ENA cameras are higher resolution and more sensitive than Ibex's. Mysteries abound. In 2009, Ibex returned a finding so shocking that researchers initially wondered if the instrument may have malfunctioned. That discovery became known as the Ibex Ribbon, a band across the sky where ENA emissions are 2 or 3 times brighter than the rest of the sky. The ribbon was totally unexpected and not anticipated by any theories before we flew the mission, McComas said. It is still not entirely clear what caused it, but it is a clear example of mysteries of the heliosphere that remain to be discovered. Our sun is a star like billions of other stars in the universe. Some of those stars also have astrospheres like the heliosphere, but this is the only astrosphere we're actually inside of and can study closely, said Justina Sokol, a research scientist at Southwest Research Institute in San Antonio, Texas. She said, we need to start from our neighborhood to learn so much more about the rest of the universe. This is by NASA's Goddard Space Flight Center on phys.org. Please leave your comments and thank you for your support.